Hello everyone, welcome back to Advent of Code. It's been a while, and this one's a video, not a stream. I'm just fitting this in when I can. You may recall that day 8, I just sort of stopped partway through. I still might revisit it. It seems like it would be a fun way to try out logic programming, which is a thing that every so often I get a little bit into, but not enough to really do anything interesting. But if I do revisit that, I'll solve it off camera in Clojure probably, and then demo the solution rather than do a whole video where I solve it on camera. Day 9, I couldn't do when it was published. I was I'm busy Wednesday nights. And then I read about it online. It just looks like more work than I want to do. So I like Advent of Code puzzles to be small. And I don't mind spending some time on them, but part 1 looks easy enough. I could do that, but part 2 again would be kind of a lot of work, I think. And I didn't really want to do it. So, but day 10, I checked out the puzzle. It seems pretty easy, so we'll do it today. Day 10, syntax scoring. You ask the submarine to determine the best route out of the deep sea cave, but it only replies, syntax error and navigation subsystem online, all of them. The damage is worse than you thought. You bring up a copy of the navigation subsystem. The navigation subsystem syntax is made of several lines containing chunks. There are 1 or more chunks on each line, and chunks contain 0 or more other chunks. Adjacent chunks are not separated by any delimiter. If one chunk stops, the next chunk, if any, immediately starts. Every chunk must open and close with one of 4 legal pairs of matching characters. And so they have just the 4 kind of matching brace pairs. Some lines are incomplete, others are corrupted. Ignore the corrupted lines. And then part 2 is to do something with the corrupted lines, presumably. A corrupted line is one where a chunk closes with the wrong character. Like where you have a closed brace that doesn't match the open brace here. If there's such a chunk anywhere in a line, the whole line is corrupted. So you ignore the entire line. Some of them are incomplete. There's an unmatched opening brace. Ignore those for now. I see. Okay, so we're ignoring them for now. We're discarding, we're finding corrupted lines and ignoring incomplete ones, I think. Stop at the first incorrect closing character on each corrupted line. To calculate the syntax error score for a line, take the first illegal character on the line and look it up in the following table. Okay. So we look through all the lines. And if we ever find a close that doesn't match the open we were expecting, then we score it. Closes with the wrong character. What about a line that's just like a right parent? Like, is that corrupted, or is that just never going to appear in my input? Because it doesn't have a mismatched open character, right? Such a chunk can appear anywhere within a line. This, by the way, seems like the kind of thing you could solve in Emacs instead of a programming language, right? You could just, jump and it'll be like, oh, weird, there's a mismatched close brace or whatever, but okay. Complex valid chunks include, okay, yeah, I understand that. The characters it opens and closes with do not form a legal pair. So none of these examples, I think, have a close with no matching open. Yeah, they're all mismatched pairs. Okay, so I guess we're gonna not have to worry about that. Grab my input. As expected, it's gobbledygook. No, don't take me to this file. No, don't paste that. Paste this. Oh no. Okay, don't paste this in Emacs. Stop. Quit. I don't trust Emacs to have pasted that correctly. So go to bash. Oh, that line looks incomplete. Yeah. Okay, I just checked my input. That is what the file ends with, so we didn't mess it up. Okay, where am I? So, I don't think we particularly need much in the way of types here. We just have import data map. Like, you could do this with just a list even, it's so small. Like, I think a map might actually be overkill here. Yeah, let's just not even do that. Let's just use a list. Well, do I need to look up opens given a close or closes given an open or both? I think you can kind of do it both ways, right? You can, when you read an open parent, you can push the matching close parent onto the stack. Or when you read an open parent, you can push it onto the stack. And when you read a close, you can look for its matching open on the stack, right? I don't think you need both. You just say, because you don't have any characters you need to ignore. It's not like there's an F in the middle that you have to say, oh, this is okay, we're only looking for parents. I can assume every character is either an open or a close. So let's just say closers is a function from char to maybe char, right? Closer is lookup. What is the type of lookup? Will you tell me? Yes. Takes an A and then a, okay, so flip lookup in so that's one close pair and another is this, and another is... Ah, hang on. I need to know scores as well. So actually, I should do a bit more here. Let's define data closer is a closer of opener, which is a char, and score, which is an int. And then we have a function from char to closer, right? Maybe closer. Closer equals flip lookup of if you have a one of these, or sure, whatever, this is fine, to a closer of open parent and 3. And then the absolutely bizarre Haskell convention for lists is to format them like this. It actually is not insane, it's just nobody else in the world uses it, so... Sorry. Oh, Haskell programmers do, but no other language formats lists this way, but that's how Haskell does it conventionally, so I try to keep up. And if we have a angle or a square bracket, the closer is of course an open bracket, and the score is 57. If you have a curly, the closer is open curly, and the score is 1197. And finally, if you have an angle, the closer is the other angle, and 25137. There. So let's just test this real quick, shall we? Closer of, it doesn't even have show, so it won't work, but it type checks, which is really all I cared about. Closer of this, yes. So we got yes. It returned something, and we can predict what that thing was. I could just put show and then it would show me, but whatever. Why is it highlighting my input as a list of strings? That looks perfectly valid. And that's all I want, honestly. It's just lines. That's my whole input. Like, great. Look at that. I wrote a parser before I even read the problem. So what am I have to, let me calculate this index, take the first illegal character and look it up. Okay. So we want a function that takes a line and produces maybe an int, right? I think it would actually turn out to be a little bit more convenient to return a list of int, but that's not very semantically correct, so I won't. Let's just write a function. Corrupted score is a function from a string. Let's say list of char, actually. I think that's a little bit more. We're actually working at the level of chars today. To maybe int. And corrupted score is surely going to go of empty list. We're going to be keeping a stack of currently open things, right? Where go of if we ever empty the input list, then whether there's anything on our stack or not, there's no score because the line wasn't corrupted. Actually, you know what would be a nice type to have? Data, data error is either corrupted int or correct or corrupted int or incomplete, and I guess we'll say it's the list of characters that are left that need to be written to finish it. Maybe we'll need to know also what characters were at the start of the line, but hopefully not. And so what we can have, instead of a maybe int, is to return error is wrong because what should we call this? Parse result. There you go. And this returns a parse result. And so it's not nothing, but if the stack is empty and the output is empty, then it's correct. Go of... If the stack was not empty, but the input was, then it's incomplete of S, where S is the closer's current, like the open parens that are still waiting on the stack. Go of S and S stack and I input, maybe, where this isn't quite right. Let's say go stack. And we'll split it apart in a minute if we need to look at what's there. So I think we'll just match all inputs in this case equals case closer I of. If there is no closer, if the character that I've got is not a closer, then it must be an opener. And we just say go I stack input, right? We take the open character we had and we put it on the stack. But if it's just expected no, this lookup is returning a closer, just of closer of expected score, and if I guess we case stack now. We examine stack, case stack of if the stack is empty, then we have a closed character with no matching open, which I think is illegal. Error closer with no matching open at all. Otherwise it's S more. Do you need? I don't think you actually need the parents there, right? And if expected equal S, then we just say go of more input, right? We matched, we got the closer we expected. And otherwise is corrupted of score, I believe. Parse error. Oh, right. It's I always arrow. There you go. I remembered it up here anyway. So let's check some example inputs for so I have some belief that this is right. Oh, I actually hang on. I have this in Emacs, don't I? So here, for example, is what did I call this function? Corrupted score of this. Okay, I'm just putting show on all my data types. Fine, you made me do it. I hate you. It's corrupted 1197. It expected... Oh, I should check. Which one of these... The first illegal character is what we should look at, right? I mean, I think that's what we're doing. We're saying the closer that was illegal, yeah. Yeah, 1197 is the correct result for that input. Cool. And if we look at, just to be sure, another of the test inputs is that. Corrupted 3, probably correct. Yeah. Whereas if we were to say, like, what is the corrupted score of that? Incomplete, we're waiting on these two. Yeah, okay, so this all looks great. Okay, cool. Let's look, we should be about ready to write part 10 now, right? It's gonna return an int, of course. We want the sum of all of these, right? Yes. Part 1 is map. Well, we're gonna do a few things. We're gonna add up the results of calling map maybe, which I'm sure I have to import. Of get score, I don't know, of we can just, instead of calling map something and then map maybe something else over it, we can just compose the two. Get score composed with corrupted score. Right? Where get score of corrupted n equals n, and get score of anything else is just n, thank you, nothing. Okay, cool. Does this work? Let's find out. Stack, run. It's a number in kind of the ballpark we might have expected. I'll take it. That's the right answer. Okay. Let's add that. Day 10, part 1. Okay. Now this time, forget the corrupted lines. The remaining lines are incomplete. Figure out the sequence of closing characters to complete all open chunks. Isn't all open chunks? There's only ever one, right? Like, it doesn't make sense to talk about there being more than one open chunk on a line. Because if it's incomplete, I don't know, weird. Add them in the correct order. Yes, very good. And then score up the stuff that's missing. Wait, what? Start with a score of 0. Oh, for each character, multiply the score by 5 and then add something. So this is a base. It's kind of a weird base 4 representation, isn't it? Kind of, maybe? I'm not sure. Okay, so but this kind of base conversion problem is usually a fold L, isn't it? It's not really a fold R. Maybe it is though, because okay, the first consider the completion string character by character, which in our case means to start at the beginning of the string we have, right? Because our string has the first character needed first in the stack. So we start with like 0, let's say. Then we multiply by x and add the value for the character. Okay, this seems simple enough. I mean, obviously it's simple enough. I'm just thinking it through a little bit. So this has our first character that we want to add first. This is fine. So this basically is going to be the same thing. Well, there's some work to factor out between part 1 and part 2, really. I'll just call this function solve. Takes a function from parse result to maybe int. Gives back a function from input to int. Solve of get score equals this. Solve corrupted score. So solve, I'm sorry, get score. So does this still work? Should. Yeah, that looks like the same number. And it is. Yes, very good. Okay. So now we just need a new get score function for part 2. Solve get score, where get score of incomplete x's equals just of fold L prime of a cum? I don't know. 0 x's? And a cum of I mean, we need like another thing here that scores open parents, basically, right? The left value should be the character, and Ac is the result we've... No, it's the other way around. Ac is what we've built up so far, and C is the character. Equals 5 times Ac plus score of C, where score of... let me just get the numbers right here. This equals 1. Score of this equals 2. Score of this equals 3. Score of this. Oh, because we want to look at the opens, right? Equals 4. 5 times Ac plus score of C, right? Oh, this is indented wrong. Yeah, it can just be part of this, right? Fold L prime from data list. Okay. Oh, yep. You're right. That warning was exactly warning me of the error that happened at runtime there. I did forget to say get score of anything else is nothing. And there is an incomplete pattern warning here, but I'm choosing to ignore it because it should be correct. Oh, that's a big number. Makes sense, I guess. Whoa, oh, it doesn't want the... It doesn't want the sum of the scores. Oh, I factored out this sum thing. I just read this far and was like, okay, yep, got it. This is how you score something, but... Sort them and take the middle score? What a weirdo. I guess they I don't know. Huh. Okay, I guess we gotta do that. Let's inline this stuff back into here, right? I guess we can just write median. Median of map, maybe get score, corrupted score. We have to implement median. Median of x is x. This is very inefficient, by the way, but it's fine. Median of this is error even number, even length. Median of x's is median of head init x's. Construct the infinite type. What are you mad about? Oh, did I? No, this looks right. Median is a function from list of A to A? Which part were you mad about? Median is implemented wrong. Okay. Head? What is init of ABC? It's AB, right? Yeah. Huh? Head.init applied to ABC should be B, right? Oh no. I wanted tail. Okay, thank you. To remove the first element, not to keep only it. Stack run? Oh. Well, I didn't sort the input, so this median approach is not going to work. We'll call it middle then. This is not really median at all. I guess I could have asked Emacs to do this replacing for me. Obviously, we could implement a more efficient median somehow, but I'm like dumb. Sort as well, please. Stack run. One more time? Okay, that's the score. That's the right answer. Okay. Well, I'm glad I caught myself before entering the wrong answer on either of those attempts. Yeah. So can't see this, hang on. I was just looking around at what we've done so far. Yeah, I mean, it's a pretty simple part 2, I think. Commit dash day 10 part 2. A lot more helper functions for part 2 than part 1, really. Yeah, I don't know. Like this whole closer thing, we needed this for both part 1 and part 2, really. And corrupted score turned out to be useful for part 1 and part 2, as we expected. It was nice to be able to categorize a line as either being part of part 1 or part of part 2 without knowing what part 2 was. Yeah. Alright. I'm reasonably happy with this. Nothing fancy, but well, we also have some partial functions, which is kind of a bummer. Several. Well. This one's not partial. We actually do pattern match on it. Yeah, but this is a little sad, you know. Anyway, I think that's all for today. Hope you enjoyed. Thanks for watching, and I'll see you next time.